legend. I have nothing to lose. Nothing can stop me. I'm all the way up. Wake up. I know what's real. Escape reality. Hardwired.
Hey folks, how you doing today? Happy Tuesday. Alrighty. Hope you're doing well. Got a couple things on tap today. We'll talk about Project 2 first, your Hold'em game. And then we'll talk about Inheritance, the first part, at least, from Chapter 10. And then we'll talk about Project 3. Alright, so again, I've got to apologize. I'm behind. This has been awful. I'm be working on getting caught up all week. It's like the only thing I have to do this week to get caught back up here. So we'll work on getting caught back up on these assignments, and then I can grade your next projects, and we'll start the project after that. This is just back to back to back this summer. It's a lot of fun, right? Hopefully you're having fun. We have gotten through actually a lot of the content. Oh no, my internet. Okay, maybe it's better. My internet does not seem to like me. Not had a lot of luck with Comcast, but we are in week 6 now of 15 here, so we're getting close to halfway. Right, we got 6 more weeks or so, right, of content, because the midterm there's no content that week. And then a little bit on design patterns. So this is almost the halfway point in terms of material, which is pretty cool. All right, so let's talk about Project 2. Everyone get a chance to turn that one in? I think I saw lots of submissions here. Uh, 15 submissions. Not as many as Project 1. Internet. What is going on here? Twitch. It's just flaky. Okay, just some little blips there. Not losing too many frames. Oh, it's not. Is it going too bad, or is it all right for you folks? No, it's not, Dusty. All right, cool, Bill. Thanks. Cool. All right, so we'll close this one, open up our Hold'em. Maybe I can close it. Awesome. Hey, Nav. So, and bonus points to Yuki for finding the bug I had in my class. Apparently, I did not test this well enough, and my 2-pair in poker hand was wrong. All the way down. What was it here? Get highest pair. This one here. Oh, that's right. I need to update. I fixed it on GitHub and I did not update it here. Cannot start at length because there is no index at the length. Right? I don't know what I was thinking when I wrote that. It needs to be -1. Come on. There we go. So I'm going to pull the change down from the central repository. because I made the change on github.com. And then it will synchronize it to your local copy, and now I have my length -1. Life is better for that one, okay? All right, so we're going to go and take a look at Hold'em here. Right, so we had card, we had poker hand, so we were going to write the Hold'em hand class and the deck class. Which one do you want to do first? Should we do deck first or Hold'em hand? Up to you folks. Hold'em, okay. Let's go add a new class here for the Hold'em hand. All right, so the Hold'em hand then, right, it had a private, you could either do card 1, card 2 separately, you could do an array list of cards. I'm not, not too concerned how you do it here. So I'll just do card 1 and a private card 2. And then we'll have a constructor. And, I want to pass these cards. So when you make a hand, you give it the cards. So I'm going to make the constructor do that work for me here. You give me card 1 and card 2, I'll take them. Sure. We'll add some get methods here. Sure, we'll get card 1, get card 2. I don't want any sets, right? I want, when you make a Hold'em hand, it will set the value, and then you can't change it. Right? That's how it should work. Right? Does that make sense? You'll have those ones. And then probably need a way to either be given the 5 shared cards or a way to store them as an attribute. Either way could work. Sure, so we'll store them as an attribute because I think that'll work nicely. So I'll just do an array list of type card for the shared cards. You could also make it just a regular array if you wanted. I think array lists are generally a little easier, but that's okay. So we'll have shared cards, and then this one now you should be able to either add a shared card, right? I kind of like the idea of adding a shared card. So I'm just going to say public void add shared card, given a card. Right, and I'll take my shared cards, and I'm going to add card. Now, the constructor's job is to initialize all of our variables. So this one needs to be initialized, even though it'll be empty. So it'll be a new array list of type card in the constructor. So it's going to be empty, and then as we draw those shared cards and put them on the table, we'll also give them to the Hold'em hand. Right, so we can add shared cards at a time. And then we'll probably have a get method for that. So public array list of type card. Sure. We'll get shared cards, just in case we need to get it. And now, remember, giving someone a reference to your private variable here is kind of dangerous. So I don't want to just return shared cards, because then they have direct access to that object, and they can add to it, they can take away from it, they can do all sorts of things here. So if I'm controlling access through an add method here, I don't want to give it back to somebody, right? That's a little bit risky. So what I'm going to do instead is I'm going to make an array list of type card called cards here equals a new array list of type card. And then I'll take cards, I'm going to add all given the shared cards. So this will add the cards themselves. Now, the cards, I'm actually giving them the reference, but cards aren't changeable, right? They're the same way. You set them in the constructor, and you can't change the face in the suit. So it's essentially an immutable object. So we're feeling okay that I'm going to give them copies, the same references to these immutable cards, because that should be fine. Right, so doing add all, it's all of the references are just getting added here. But it's a different array list. So if they change the array list I'm returning, it's not going to change my list of shared cards. So add all is great, or you could loop through shared cards, add them one at a time. Any way you want to is okay. So this is making sense so far. So we've set up our private attributes. We can give 2 cards when we're created in the constructor, and then we can add shared cards one at a time as we go. And maybe we could even add in something here, like if shared cards dot size is greater than 5, right? We want to raise an exception. So we'll throw invalid argument. I don't know, some illegal argument more than 5 cards. This is probably overboard, but just, an idea of if something's going wrong here, we want to throw an exception. Uh-oh. must be caught or declared to be thrown. What? No. Can't find symbol? Oh, new. There we go. Missed my new keyword. So we'll throw a new exception. Again, this was optional, right? Just a nice idea. Or maybe we even check before we even add one. Sure, we got lots of options. It's probably better to actually check before then, right? So if we are at 5, right? If we have 5 and we're calling add again, throw this exception. So when I have 0 shared cards, 0, 1 shared card, fine. This will be fine. If I have 5 already, then I'm going to throw that exception and try and add 1. Again, just a good idea, like this idea that our classes here are protecting their integrity. We'll make sure we don't have more shared cards than we should. Okay? All right. Then what we're going to do is we're going to have a method that will return the best possible poker hand. Best possible hand. Okay? And now, again, we could check our shared cards.size here. If it does not equal 5 in this case, throw something about state, I don't know. Illegal state exception. That's probably right. Sure. Must have 5 shared cards. Again, just another, we want to protect ourselves, because if we don't have 5 shared cards, we're in a bad spot. We're in a bad state. You can't get the best possible hand until you have 5 shared cards. So it is possible, too, that you could also like require that you're passed as an argument the 5 cards here. I've done it that way before as well, instead of adding them one at a time. Both ways are fine. Just depends on what you want to do here and how you're managing those shared cards. It's ginger kombucha. Stuff is so tasty. Okay, so then what we need to do is we need a new array list of type card for all cards. Equals new array list of type card. Oh yeah, we can just use the diamond operator, right? We don't need to tell this card again. And then we'll take all cards, and we're going to add all the shared cards. Nope, okay. Add all shared cards. There we go. And then we'll take our all cards, and we're going to just add card 1, and we'll do it again. We'll add card 2. This means we have 7 cards. And if you want to do it in the same order, sure. The order doesn't matter, but this way it'll match perfectly. Okay, so now all cards will have 7 cards, because we know we have 5, and we know we have 2 here from our constructor, so we're going to go add them. Now we have 7. So now what I need to do is I need to pick all possible 21 poker hands. So I'm going to make an array list of type poker hand, called hands, equals a new array list of type poker hand. We just diamond, right? We don't need to tell it again. So I can start adding it here. So I'm going to loop. So I'm going to say for int first card index starts at 0, and first card index is less than 3, or less than or equal to, whatever you prefer. Because 0 is okay, 1 is okay, and 2 is okay for the indexes. I mean, I shared that in the Discord. We did all sorts of counting. Here, these are the possible values for that first card. We'll take the first card index plus plus. And we're going to do this 5 times. Right, we're going to have a second card index. Now, it can't start at 0, and it can't start at 1, because it needs to start at whatever first is plus 1. Because if first is 0, I'm going to start at 1. If first is 1, I'm going to start at 2. If first is 2, I'm going to start at 3. Because we can't have a duplicate card. So I need to start at them plus 1. We'll just keep on working our way down through the loop. Do another one here for third card index. It's the second card index plus 1. Third card index is less than 5. And third card index plus plus. And again, sorry, it's going to get a little wide here, but my font's a little large, so hopefully it fits better on yours. And then we'll do the fourth card index. Fourth card index starts at third plus 1. Fourth card index is less than 6. And fourth card index plus plus. Right, so 5 is good. And then one more. For the fifth card index. Fifth card index, it starts at fourth plus 1. It goes to less than 7. And it goes up by 1 at a time. Okay? So each of these loops here, these nested loops, will give me the next possible card. So I'm going to get all the index zeros, all the index ones, all the index twos, all the index threes, right, for the first 4 cards, and then I'm going to get a 5, a 6, and a 7. Right? 5, 6, 7. All 3 possibilities. Okay? So what we need to do then we're going to pick all these cards. So if you look at Poker Hand and the constructor wants an array list of type card. Okay, sure. So I'm going to make an array list of type card. This is my cards equals a new array list of type card. Just diamond, that's right. Then we're going to go add each of those indexes from the all cards. We'll take cards dot add all cards dot get first card index. Okay, that adds the first card, and the second card, and the third card, and the fourth card, and the fifth card. Second, by the way, if you haven't noticed, that double clicking will highlight an entire word. Triple clicking will highlight the entire line. That's how you do those highlights real quick. Okay, so we add all of them here. Now we have a new array list. We have all 5 cards. We can make a poker hand. Poker hand equals new poker hand. Given the cards. All right, given the 5 cards, now we make a poker hand. And I can take my hands and I can add the hand. So this will run 21 times, because we've done all that math, right? To make sure that I'll get all 21 possible combinations of cards. So I'll have all 21 poker hands. Then what I need to do is I need to find the largest one. So if you think back to when you first talked about arrays, they probably showed you, definitely should have showed you, how you find the largest or the smallest number in an array. Right? The idea is you take the first one and you assume it's the biggest or the smallest, whatever you're looking for, until you know otherwise. So we're going to have a poker hand called the best hand. It's going to be the first one until we know otherwise. So that's my hands.get 0. So the first hand is the best hand until I know otherwise. Then I'm going to loop through. So again, you could start at index 0, but it's not going to matter. So it's probably a little bit more efficient. So we'll look at hand index. We're going to start at 1 because we already took 0. Either way is okay. It's not too big of a deal, but this is probably better to start at 1 here. Like you do one less check. Sure. Hand index is less than my hands.size. Hand index plus plus. I've debated about this because it's always best to do this less than size, but going less than 21 might be good in case you don't get 21 combinations, just as a sanity check. But again, it should be fine. So typically you always want to go less than your size, because that way you're not going to crash. But maybe you want to crash if you don't actually get 21 possible hands or something like that. So unless you like to run this in the debug mode and watch it, which is fun too. All right, now we're going to see which one is better. Remember, poker hand can already tell us which one is better. It will compare to. Right? Oh, we do get a 1 negative. Okay, I thought compare to it's just positive. That's fine. I am mixing myself up here. So it's either going to be positive number if we win, negative number if we lose, or 0. So anything greater than 0 is going to work. So we want to say, hey, if my hands.get at the hand index dot compared to the best hand. So compare the current hand to the best hand. If that's greater than 0, I have a new best hand. Right? That one must be the new best hand. And it's probably better. You could have done equals 1. I think I led someone wrong because I forgot, and it's hard to do this stuff on my phone, hours before it's due. But if it's greater than 0, it means compare to says it's better. So it's usually better to use. I know we know that it's 1, so it would have been safe, but it's probably a better practice. Okay, and we're done with that. We're going to return the best hand. This will look at all 21 hands, assuming the first is the best. Look at the next 20, comparing them. If we find that one that compares better, that's their best hand. So we can return the best hand with get best possible hand for a poker hand. Right? 5 nested loops, get the 5 cards, get the 21 hands, find the best hand. I think that's all what we talked about, right? Feeling okay so far? Then we wanted to implement comparable of type Hold'em hand, or add the call method. Either one was okay. It was up to you, right? So how we compare? Right? Well, we're going to compare our best hand to their best hand. So we're going to return best hand, or get best hand, dot compare to the other, right? I prefer other to O, so other, get best hand. That's it. It already knows how to compare to, right? Because we can compare poker hands. I gave that one to you. So for a hold'em hand to compare itself, it compares its best hand to the other's best hand. And that's the beauty of this being a instance method. If you have a hold'em hand, you can compare. If you have a other hold'em hand, you can compare. And life is good. So if you wanted to do a call method, right? So if you wanted to do public, poker hand dot result call against a poker hand or hold'em hand other, right? We could do that too, right? One hand calls another hand. We do the same thing. Get best possible hand dot call the other dot get best possible hand. Right? Either one, because poker hand already knows how to call another hand to see which one wins, and you'll get that win, loser, draw, enum. Right? We had call in here. It's going to return that result. That makes sense so far? Okay, and then we wanted to write some tests. We wanted to make sure that I can get the best possible hand, right? If I know what 7 cards it has, I should know what the best 5-card hand is. And I should be able to take 2 hold'em hands and say this one should beat this one, given the 5 shared cards. Yeah, call, it's just using our best hand calling their best hand. Because poker hand already knows how to call. And it's all about your best hand. I'm just going to use that same result enum. If you wrote your own enum again, sure, fine. You probably did more work than you needed to, but that's okay. So again, it's my best hand calling their best hand, other best hand. Same thing we do with compare. My best hand compared to their best hand. Because what you do with a hold'em hand is you generate the best possible poker hand. And that's how we compare these. They're based on their 5-card poker hands. Just if you're curious and got into poker, there's also another variant called Omaha, which has a similar idea, but you have 4 individual cards, but you have to use 2 of yours and 3 of the shared ones. It's kind of a fun little thing. And then you can also play like best hand and a worst hand. It's a high-low version. There's all sorts of fun ways to play poker. And the odds are very interesting, and the statistics behind it are really fun. Okay? You all right so far? Should we do the tests? So let's go to navigate, go to test. Yeah, write some JUnit 4 tests, please. Okay, so I'm not going to test the gets. That's fine. I'm not going to test the adds. The best possible hand is what I want to test right now. I'll test the compare to and call in a little bit here. Okay? All right. So, the best possible hand. So if I give it 7 cards, right, so I'm going to need a hold'em hand with some cards and 5 shared cards. Right, so we'll say, we'll make a hold'em hand equals new hold'em hand. And let's give it, okay, let's see. So if we give it card dot, or a new card given card dot base dot, what should we give it here? How about a straight? Is a straight fun? Straight might be fun. So let's do like a 7, sure. And card dot suit dot, the suit doesn't matter here, right? Because it's just a straight. 2 cards, sorry. You have to give it 2 cards. 1 and 2. New card, how about then we'll give it the 8 of clubs? Sure, why not? Okay, so we'll make the hand, and then we'll take hand, and we're going to add a shared card Given a new card, let's add some more cards. So let's add, how about the ace for fun to make a high one here. That's 1, so we need to add 5 shared cards. 2, 3, 4, and 5. So if we want a straight, one needs to be a 6. And how about hearts, right? We want to change this up so we don't get a straight flush. 6, 7, 8. How about a 9? And then, I don't know, how about another ace of diamonds, maybe? And then like a 2, I don't know. Sure, 2 of spades. Okay, so we should take the 7, the 8, the 6, the 9. Oops, I need one more. I can't even count. So let's make that the 10. Okay, so 7, 8, so 6, 7, 8, 9, 10. Should be what I get here, right? When I get my best possible hand. Right, so we're going to arrange. We're setting up hand here. And then we need to set up a poker hand. Right, this is our expected hand. Equals a new poker hand. And this one needs an array list of type card. Oh my goodness. Okay. We need to build an array list of type card. New array list of type card. Cards.add. And let's add these ones here. Okay. Yeah, we want to add array list. So we did the 7, the 8, the 6, the 9, the 10. Right, that was hearts. 6 of hearts. It was an 8 of clubs. It was a 9 of clubs. And it was a 10 of spades. Okay, and we'll give it the cards list here for the poker hand. That's our expected hand. Now we're going to act. Now, maybe this was act. I'm not too concerned. That's okay. So then we're going to get the poker hand actual best hand, or actual best hand, equals my hold'em hand, or hand, get best possible. And we're going to assert. Now, if you remember with objects, with classes, we don't have an equals method here. So if I just assert that they equal, what are we going to get? We're going to get, are they the same object in memory? Which they're not. So I need to assert something else that they're the same. I gave you a toString here, right? There's a method toString. Where'd it go here? Rank, result, toString. Here we go. So toString will give us all of the cards, right? Including the hand rank. So I think toString is a pretty good equivalent here. So we're going to assert equal that my expected hand toString is equal to the actual best hand toString. Do the two strings match? And we'll see if they do. See what we get. And it passes. Look at that. Get best possible hand. So, given 2 of our cards, 5 shared cards, we pulled out the straight. Okay? Right? And if you were getting errors here that they didn't match, right? If we took out those 2 strings and you tried to run that test, test results. You run that one, it's going to fail. Right? Because they're not the same object. Now, it gets confusing because it looks like it matches because it's showing you the toString result. Like it automatically is taking that object toString. So it looks like they match, but they don't, right? So just put the 2 strings back. So I think like 2 or 3 people had trouble with that. And I helped them out with that one, that you can compare 2 strings. So, okay, we correctly calculated the best possible hand. I feel pretty good. You don't need to do every single way that you could have a best hand, right? Just, did I get the best one? Okay? And sure, and I don't know if there were any other interesting hands here, but we got that it was a straight. Right? I think that was in the result, right? Yeah, it knows it's a straight. Okay, and then compare to, I want to give it 2 hands. One should be better than the other, and it should win. If I compare the two exact hands, they should tie, and like the opposite, does the other one lose to the first one? Right, so we'll compare to wins and loses. Sure. Let's make two sets of hands. Okay, so sure, we'll do the straight for 1. Here's, I don't know, first hand, or winning hand. How about that? Winning hand. And then how about a losing hand? We'll do this again, essentially. The losing hand. If we don't have a 7 and an 8, right? Maybe we have another ace. Ace of clubs. Oh, we can't have two aces of clubs. We'll do that ace of hearts, right? We'll get a pair of aces here, right? But then we don't have a... Oh, that's 3 aces. That's fine. We'll have 3 aces. Right? Hearts, clubs, and diamonds. That'll still lose to the straight. The losing hand, then, if we add the shared cards, right? They should have the same set of shared cards. Again, we're not actually checking that, but that's okay. That'd be another nice thing to check. Like, do they both have the same set of shared cards? But that's probably above and beyond what we need to do. So if I have these two cards, an ace-7 versus a 7-8, I should lose, right? The losing hand should lose, the winning hand should win. So then in our act, we're going to call compare. So we'll have an int winning result equals the first, the winning hand compared to the losing hand. Right, and then the losing result should be the opposite. If I take the losing hand compared to the winning hand. Okay, and then I'm going to assert. So we'll assert equal. Actually, maybe just even assert true, right? We'll be lazy here. That the winning result is greater than 0. And then we'll assert false. Or yeah, we can just do true again here. The losing result is less than 0. Right? Did I get a positive number for winning? Did I get a negative number for losing? Because compare should work both directions. So let's test that one. Okay, feeling good about that one. And then for call, maybe we'll do this one where we draw, right? So this is a draw here. We'll do 2 of the exact same hand here. Sure. We're close here. So this will be like the first hand, then. Right, and this will be the second hand. If it's the same cards. Okay, so these should be a little bit different then, right? So 8 of, how about spades, and 7 of hearts, sure. 7 of spades, 8 of hearts. Just to make sure the cards are different there, right? The same set here. The poker hand, result is first hand, call, second hand. Okay? Then we're going to assert that... Oh, come on. There we go. Assert equal my result. Oh, I should have the expected result, right? So an expected result. Poker hand dot result. Expected result. Poker hand dot result dot draw. And this will be my actual result. My expected result is the actual result. Did we draw? Let's run this one. Okay, so that should be good for the unit tests. Again, we don't need to do anything super exhaustive, but like we want to test the ones that we wrote and make sure we got good code coverage. So in terms of code coverage, right? Well, really, one of these would do it, but we want to make sure we can win and we can lose and we can draw. So testing win, lose, and draw on each of these should be pretty good. Okay? Any questions on the testing? Wasn't looking for a whole lot there, but you know that you can get the best hand and you can get win, lose, and draw. Whether or not you did call or compare to. Either was fine. Alright, cool. So now we need deck, right? We need a deck of cards that we can get random cards out of. Either we can shuffle the deck and just take the last one, or we can just get a random one out. Either's perfectly fine. So deck will have private array list of type card for the cards, right? And I have in here, right, how we get all the cards. So I'm just going to take that actually out. I'm just going to cut it out here. And public deck. Instead of doing that, we're going to add them here, right? So we'll set up cards equals new array list. Oh, we got to import array list. Yep. And we'll take cards.add, a new card given the face and the suit. Right, is that the right direction? Card, it wants face and suit. Okay, card, face, and suit. Cool, so we get a new card given the face and the suit. Then when we're done, we want to shuffle them. So there's this collections.shuffle, I think I told you about, collections.shuffle. We can shuffle the cards. Then when you want to draw a card, public card, I don't know, take card or something, get card, take top card, deal card, sure, deal. How about deal? We'll return cards dot, and we want to, remove, which one? Now, if you remove the first one, they all have to shuffle down, so that's not ideal. We want to do cards dot size -1. If you remove the last one, it's usually not too big of a deal. Because, I mean, again, we haven't really talked about that. Don't worry about it. We talked about it in data structures 2353. But removing the first one means everything has to slide down and that's slow. Removing the last one means you just take the last one off and you're fine. So removing the last one's probably best. It's not going to matter one way or the other, but for our purposes, it shouldn't really impact anything because these are small. Okay, not talking about anything in the bazillions. Right, that's deck. Okay. So in main, then we need to we can make a player class if you want. I don't think I required a player class. I gotta remember this now. Let me go look up. So if you want player to track their money, great, and the player could have the hold'em hand. That's fine, but right, two cards to the player, 2 cards to the computer. That's their hold'em hand. Given the 2-card hand, the 5 share cards, make the best card hand. You need to write the hold'em hand class, calculate the best possible hand. See if we lose or draw. Don't let them bet more than their opponent. Start the player off with $100, alternating. All the rounds of betting we have to do. More betting, and then if you actually win or not. And then we'll check the rubric. Private variables for 2 cards. Oh, okay, so I did say it should be private variable for the 5 cards. So it's better to have that there. Call and compare. Best possible hand, and calling, unit tests. Yep, the unit tests. The hold'em game itself, the hold'em game, don't let them bet, and the hold'em game keeps going until someone gets bored. All right, so we don't need a player class. Not too big of a deal. So we'll have an int for player money is 100, and an int for computer money is 100. Right, and we're going to loop as long as someone still has money. So while player money does not equal 0, and computer money does not equal 0. We want to keep on going. Right? Sort of idea here. This is what's going to keep us going. Okay? Then what we want to do is we want to play around. So we're going to pick who needs to go first. So it'll be like a Boolean for player starts. I don't know. Player bets first or something. We'll assume it's true. And then we'll just flip this one back and forth every time. Why not? So we'll have an int for the start of the loop. The int for the pot starts off at 0. Oh, really, it's going to start at 3. I don't know. Start at 0. Sure. And we'll take the player money. I guess we want to say as long as we're greater than 0 then, right? And if it's greater than 0. So the pot, we'll just add the $3. I don't know. We probably should do some sanity checking, make sure we have at least $2 to play. Because if you don't have that, then you're not going to be able to play around. So as long as you're greater than 1, I guess, you'll have at least 2 to do the betting, and you should be fine. Okay, so we'll set the pot off at 3. We'll take player money. So if the player bets first, then player money -2, and the computer money -, else we do it the other way around. Computer loses 2 and the player loses 1. Right? They bet 1. Player money. Okay? And then either way, the player bets first equals not player bets first, right? Take the opposite. flip it for next round. Or maybe we do that at the very end. Maybe we'll do that at the very end. Because we'll see who plays first. Okay, so we have some initial money in the pot. We need to deal some cards. We need the deck. So deck equals new deck. Sure. And then the player hold'em hand. Player hand equals a new hold'em hand. Given deck.deal. Deck.deal. Right, give it 2 cards. Cool. Make a computer hand. New hold'em hand, deck deal, deck deal. Great. Now we have our cards. So if we want to be able to display the cards, probably only really care about their individual cards, right? When we 2-string. So maybe we write a 2-string. Public string, 2-string. And Poker Hand knows how to do this already. We probably don't even need a string builder, do we? Yeah, just 2 cards, that's fine. It's just 2, so we'll just return card 1, dot 2-string, plus a space, plus card 2, dot 2-string. String builder would be slightly better, but I think, you know, this one concatenation I'm not too worried about. So here's my first card, my second card. Right? Cool. So I can 2-string that in my game. So we can say the player's hand. We'll print out, right? Player's hand. Player hand, that 2-string. Okay? And then if they bet first, right, then it's up to the computer. The computer's probably going to call. Right? Otherwise, it's really boring. We'll have some randomized here. So then if the player bet first, then we'll assume the computer calls this one. I don't know. I did say random, but maybe, yeah, maybe they fold. So sure, we'll do random. So let's make a random. Random equals a new random. We'll import random. So if the player bet first, we'll say if random.nextInt going to 2 will give me a 1 or a 0, right? A 0 or 1. If it equals a 0, then we'll assume the computer calls. Computer calls. And we'll take the computer money, minus, minus. Else, the computer folds. And then we'll take the player money, plus equals the pot. And really, that's it. And then we should end, or we should go to the next iteration of the loop, because we don't need to do anything else. So maybe this is a good time to use that continue keyword or something. I don't know. Maybe that's fine. Continue. I don't usually like continues, but maybe that makes sense, right? That we just, okay, sure, we go to the next round. Right? Ends the round, starts the loop again. Right? Should be fine. If that's too terrible, let me know. I'm a little embarrassed I'm using a continue, but it's probably fine. So the player didn't bet first, right? We're going to ask the user. We want to call, raise, or fold. Right? Our different options. So I can call, I can match the $2 bet, I can raise, which bets more than $2, or I can fold. Okay? Then we need to get some input. All right, so let's go set up a scanner. So scanner keyboard, with a new scanner, given system.in. It's actually a lot to the betting, and it's not even worth all that many points in comparison to the project, but that's okay. I mean, we were mostly supposed to be dealing with classes here. Okay, and we'll get some, I don't know, string for choice equals a keyboard.nextLine. Right, and you know what? We actually just did this in the other class here, and I'm kind of tempted to do another method for this, because this is getting kind of big and ugly in main, and we should break this out into methods. And like this is a really nice one, because we're going to ask this a lot of times, right? So let's do this refactor. We want to introduce a method called call, raise, or fold, or prompt for, sure, prompt for call, raise, or fold. Look at that, we can even hand it our scanner. then we can return the choice. Sure, string. String for choice. We'll return that. And we might as well even do the validation in here, right? So why not? So we'll say string choice equals nothing. And while choice does not equals ignore string, ignore case, call, well, it does not equal that, and it does not equal raise, and it does not equal fold, keep them inside this loop, right? Do this little input validation loop. So start off as empty. It is not call, it is not raise, it is not fold. The loop will run. Ask them, hey, do you want to call, raise, or fold? They enter a choice. If it's not call, raise, or fold, the loop stays. And eventually will return choice. I like that. So now we're prompting. So now we get their choice. Right? Should we ask how much they want to raise? We could do that somewhere else. Yeah, we'll make that another method too. So if choice equals ignore case, if it equals fold, then you fold the computer money gets the pot, and then we'll continue. Right, end of the round, starts the loop over again. Sure. If it's not fold, right, else if choice equals call, that's probably the next easy one to look at. If it equals call, then we need to put in our other dollar. So pot plus equals 1, or plus plus, plus plus, player money, minus minus. Right, add the dollar to the pot, take a dollar away. And we can even tell them you call if you want. I don't know, you call. Right, else, sure, we don't even need to check. I guess we could check raise, but that's fine. How about we have a method for get raise amount? So put pot plus equals get raise amount. Probably given the keyboard here. Right, now this is going to need some logic though. Right, so I'm feeling a little bad here. This is getting a little ugly here in our game, but that's okay. So we actually want to make these available everywhere here. So I want these to be static variables so that I can get at them from all my methods. Right? I want to be able to get them from all the methods. We might as well do that with scanner too, right? I think that's static scanner keyboard. Okay, cool. So I don't even have to pass keyboard. We can get rid of that. We don't need to pass that. Okay, so we need a method for the get raise amount. So private static int get raise amount. We'll prompt them. How much do you want to raise? And we need to check, right? So to make sure that we're not betting more than the other player has. Right? Because we're not allowed to bet more than they have, because then they can't really call. There's ways to do it, but it gets more complicated. Believe it or not, that would make things even worse. Okay. Bill 9, thank you so much for donating your Prime sub there to the Student Scholarship Fund over at the University of Michigan Dearborn, where I'm a lecturer and a student. It's pretty cool. I needed to make my donation. I just got the notification last night. Twitch finally sent me some money. Super excited to donate that. So I've got 50 already in. I got to put the rest of it in. Super excited. And I'll show you all the receipts later. All right, so we need to ask how much they want to raise. We need to make sure they're not raising more than the other player has. Right? So first we need to call. Right? So for this first round, yeah, all of this is probably like, yeah, I'm not loving this because we do this over and over and over again here, right? That's all right, we can take care of that after. So how about we do that? We'll do that as like a current bet here. Yeah. Okay, this is good. So if you choose to raise, you're calling initially, right? So we'll take the pot plus plus, and we'll take the player's money, player money, minus minus, right? That's the call, and then we'll get the raise, right? I like that. So this is going to have to change here in a second. So we need... So if the player bets first, computer calls or folds. Otherwise, it's up to the player. Okay. We'll come back to that. We can fix this up later. This is surprisingly more complicated than the rest of that. That's okay. So we have an int for bet. Starts off at 0. Sure. And yeah, how much they want to raise. And then we'll set... Yeah, we don't even have to do that, right? Say int bet is equal to integer.parseInt given the keyboard.next line. And then while bet is greater than the computer money, we'll say can't bet more than, or you can't raise more than $sign plus the computer money. Ask them again. I like that, right? And then when we're done, we'll return the bet. That should be raise, right? Raise. Okay, because that way we're making sure we're not going to bet more than the computer. Okay? That part makes sense? And again, computer, we made it static, so we have access here. Otherwise, we have to do all this passing back and forth, and it's going to get messy. So we'll get the raise. It adds that to the pot. Then the computer needs to decide whether or not they want to call. So really, we need like another place here. So this will be the, how about an int raise amount equals the get raise amount, and then we'll take the pot plus equals the raise amount. And then does the computer call or fold? Okay, so we need to know whether or not the computer calls or folds, because it's either going to take some money away from them or it's going to add their money to the pot. Well, if they call, the pot needs to go plus plus, right? Add to the pot. Okay. Then we need to see if the computer is going to call or not. Sure, we'll do another if else. But now it's the raise amount. Computer call, so computer money minus equals the raise amount, the pot plus equals the raise amount. Otherwise, they fold, the player gets the pot. That makes sense, I think? So that's the first round. Oh my goodness. All of that happening for the first bet. Right, then we get 3 shared cards. All right, so the first shared cards. Shared cards. Sure. So we need to go get the cards. So we'll have card, shared card 1 equals deck.deal. Shared card 2, shared card 3. Right, we need to add all of those then. So by the player hand, add shared card, given shared card 1. We'll add all the shared cards. Shared card 2, shared card 3. We'll repeat for the computer hand. Right. Add the shared card, add the shared card, add the shared card. And then probably tell them what the shared cards are, right? So plus shared card 1, plus a space, plus shared card 2, plus a space, right? Plus shared card 3. Plus. All right, how's that look? So we'll print out the shared cards. Oh, that's too much there. We need to do another round of betting. So all of this like round of betting stuff we want to take out essentially, right? Because this is going to happen over and over and over, just with different numbers. Right? So if the player bets first, then the computer's either going to call, right? Call or bet, or they're going to fold. So if the player bets first on these other rounds, right, for this next round, oh, we got to check they don't bet money they don't have too. Oh goodness, that's another check here. So making sure in our raise money is greater than the computer's money, or raise is greater than the player's money. Again, if either one of those is true, we need to keep asking. Raise more than computer money. Ooh, we actually just need to see which one is the largest, right? So we want math.min of the computer money and the player money. Right? See which one is the minimum. Because we can't bet more than we have or more than they have. I like that. Yeah, so all of this then is going to happen. So I guess the call is different. So what do we have, like the current raise? So I guess we have this raise amount, right? So the computer's always just going to call 0. So we should have a raise amount. So we'll have an int for raise amount is 1. That's for the first one, right? Minus equals the raise amount. Pot plus equals the raise amount. And then if they fold, the player gets the pot. If the player calls, they'll minus equal the raise amount. The pot will plus equals the raise amount. And the player money minus equals the raise amount. Then we change the raise amount, I guess. Sure, why not? I think that works. Like all of this then can be a method, right, that we call a bunch of times. And raise amount is essentially what's going to be different each time. So let's do that. So I'm going to take all of that, right, that's all this one loop here. We're going to introduce a method. This is betting round. Sure. Oh goodness, that didn't do it exactly what I wanted. That's okay. So we'll have betting round given. Oh, because it needs to be able to tell all the continues. Shoot. All right, that gets a little bit more obnoxious then. Okay. So the player bets first. Can make that static too. Why not? I'll make that static. We don't need to pass it. We don't need to pass it to random. I guess we don't even need to pass it to pot either. We can make all those static, right? Static int pot, static int, or static random. Yep, here we go. All right, this should probably be its own class now, and I'm feeling bad, but it's okay. If betting round, so if we return a true, we should continue, I guess. Betting round. We can name this better. This should be, well, this is a betting round. Someone did someone fold? Here. So betting round, did someone fold? If someone folds, we're going to hit continue. Right? So what do we need here? We don't need any of that. We don't need any of that. We need the int raise amount. There we go. So the first round then, the raise amount is 1. For betting round, did someone fold? For the other rounds, the raise amount starts at 0. So like the computer will just call a 0 bid, and they're not going to lose any money. Otherwise, they really shouldn't even fold, I guess. Alright, I'm not in love with this. I'm sorry. I don't know why this is so hard. I guess that first round is different because they had the auto bets. But otherwise, if the player bets first, then we should ask them if they want to bet. Ugh. Sure, we'll just do this. We can say if raise amount equals 0 and the player bets first. Then we'll ask the player if they want to bet. Call, raise, or fold. Hey, Miad, thanks so much for subscribing with Prime. That's so cool. Thanks for donating your Prime sub to the Student Scholarship Fund over at the University of Michigan Dearborn, where I'm a student and a lecturer. It's kind of fun. That's so cool, you guys. Oh, goodness. This is a different scenario, right, for this raise amount. We just ask the player if they want to bet, I guess. Here. We'll do that. We will do that. So, if player bets first, and here, oh, that's only for the other rounds, though. We skipped this one for the first round. Okay. Okay, so we'll set this through initially. We'll run it here. And this is with the initial $2, $1 bets. Great. That's round one. Then, if the player bets first, we need to ask them how much they want to bet. Right? So then we'll prompt for string choice equals prompt for call, raise, or fold. And if choice equals all these things, then we need to do certain things. So if, there we go. If the choice is fold, they should not fold, but that's fine. Here. Okay. So if they fold, they're not going to fold. That's silly, but okay, why not? We'll just continue. If they call, then no money changes, and then the computer will call as well. It's really like a check at that point, but that's okay. So system out print line. Computer calls. If they didn't fold or call, then we need to go figure out how much they're going to raise. So then that's a betting round, right? And what do we do with this one here? I have too many curly braces. Did I mess that up? What did I do wrong? I don't know why that's upset. Legal start of expression. Oh, yeah, I don't have enough curly braces. What did I do? Lost a curly brace somewhere. If, else if, else. Should be the while loop. Oh. That's the wrong one. If needed some curly braces. There we go. Okay. Sorry about that. Okay. Oh, so the first round, right, then we print out their hand. Then we do the shared cards. Oh, that's okay. Something's ugly here. I'm sorry, folks. Losing my curly braces. All right, so first round of betting for the $1, and that was the raise amount. And then the computer would either call or fold, and then sure, they could fold as well, I guess, or if they didn't bet first. All right, so if the player bet first, then they need to decide whether or not they want to raise or fold. Then the raise amount, int raise amount equals prompt for raise amount. Oh, where'd it go? Didn't we have that as a method? Get raise amount. There we go. Get raise amount. So that's really like the bet. Sure, why not? How much you want to raise? That's fine. And then we'll call this betting round. We can do this again then. Betting round. Given the raise amount. Rip. What's up, King? But not going well? Man, I'm dropping more frames. What is going on? It looks mostly stable. That's weird. So if the player bet first, the computer's either going to call the raise amount, and if they didn't bet first, then sure, well, yeah. King, that's rough. Yeah, this classes keep moving. All right, so if the player bet first, right, that's going to happen. If they didn't bet first, then we want this round to happen with no raise amount, right? They can call nothing, right? Sure. So else, we'll do a round of betting, given a $0 raise, because the computer is never going to raise any money, right? The computer's just dumb here. Okay, oops, we didn't switch yet. All right. Oh my goodness, we're getting there. So this is round 1 of betting, right? Then we'll get another shared card. Do the same thing kind of going on here. Shared card 4. Add shared card 4. Add shared card 4. Then we could print out probably all the shared cards, right? Might as well print them all the time. So we know what the shared cards are. Okay, and maybe we print out their cards as well, right? Before we make the bets. Print out the player's hand. Do the round of betting. Print the shared cards. Print out their hand again, maybe. Why not? The shared cards. Print out their hand. Essentially, you're going to do this again, right? Yeah. So the next round. So here, we're going to do all of this again. So let's see if we can do that. We'll see if we can introduce... Ugh. This is ugly. I'm sorry. Why not? This is with 4 cards. Do around the betting, and then we'll do it again with 5 cards. This is one ugly main method, folks. I'm sorry. Share card 5. Add the share card 5. Add the share card 5. 4 plus a space. Share card 5. Player's hand. Bet, fold, call. All right, all of this then. Oh my goodness. If we did not fold and continue, then we're going to actually see who wins. Right? So we'll print out the player's hand. Print out the computer's hand. Computer's hand. Computers. Computer hand. 2 string. And then maybe we print out their best hand, right? Why not? Right? We can do all of these. Player's best hand. Player hand get best possible hand. And poker hand already knows how to 2 string. So we can do that. Computer's best hand. Okay, and then we'll figure out the win, lose, or draw. So then if player's best hand. Hey, Stormstacks, thanks so much for donating your Prime subscription there to the Student Scholarship Fund over the University of Michigan Dearborn, where I'm both a student and a lecturer. It's kind of fun. All right, if my best hand compare to the computer hand, get best possible hand. If that's greater than 0, maybe we should save that as a result, right? That probably makes sense here. So let's do that. So we'll have an int for result. Goodness. We can also use call, right? Whichever one you want. Result's greater than 0. So player wins. And then the player money plus equals the pot. Else if the result is equal to 0, we draw. And the player money plus equals the pot divided by 2. And the computer money plus equals the pot divided by 2. Else computer wins. And the computer money plus equals the pot. Right, and then maybe we spit out how much money they have. Peter has... Maybe we'll do this at the beginning. We'll do that at the beginning. Why not? Has plus the computer money. And then the player has the player money. All right, sure. And then we'll set the pot. We'll do all this. This may or may not work, folks. I'm a little embarrassed. I'm sorry. This loop is a lot uglier than I wanted it to be. Should have been a lot prettier. Like some of these methods, I think using continue. This is why like using continue is hard because then you can't use continue in another loop anyway. Ugh. Yeah, could have been better. It's okay, right? As long as it works. Let's see if it runs. We want to try it. And the computer's going to fold way too often anyway. All right, so we had $100. We went first. We had 5 of hearts, 9 of hearts. The computer calls. We have 9 of spades, 6 of clubs, 3 of diamonds. We have 5 of hearts, 9 of hearts. So what do we have? We have a pair of 9s, it looks like, so far. So let's just call. Okay, we called. Great. Now we also added a 10. So what's here? Still probably the 9 is good, so we'll just call. Computer calls. Right, the next shared card is 7 of spades. 5, 6, 7s, 9. So nothing great. No straight here, so let's just call again. All right, the computer wins. Uh-oh. We had a pair. They had 2 pairs. The computer had a 7 and a 10. And the shared cards were a 7 and a 10. Okay, yep, so they had 2 pair. Computer wins. Hey, King. We're losing to the computer. Uh-oh. Something's wrong with the pot, though, here. That should have been 4. So when our pot was here... Oh, that's why. Maybe we had a pot up here. That ought to do it. We're going to use that pot. Okay. That was probably it. Let's stop it and try it again. We don't even have like a way to stop the game, right? To just end it. There's no way for them to just quit. I guess we could ask them at the very end, right? We'll try one more time. This is Hold'em. Okay, so we went first. The computer calls. So we have a 6 and a 10. And there's a 6. All right, so we have a pair. Sure, well, let's call. All right, so there's an ace, there's a 5, there's a queen. We'll call again. There's a 6, an ace, a 5, a queen, and a 9. We have a 6 and a 10. Oh, so we still have a pair of 6s. Might as well call. Oh, the computer won again. They had a better pair. They had an 8. We had a 6. Bummer. All right, sure. So now we have a 6 of diamonds and an ace of spades. Let's call. Maybe we can do some more outputting too, like some better betting. All right, so let's raise. See if we can get the computer to fold. Let's raise 10. And the computer folds. We win their money just because we bet. Uh-oh. Should not have that much. Did we not take it out when we raised? The raise amount, so we're not subtracting that from our money when we raise, do we? Pot plus the raise amount. Ah, there we go. And then, so the get raise amount, we need to subtract that from our money. So player money minus equals the raise amount again. Yeah, they're a lot of fun. All right, but that seems to be the gist of it. You folks holding up okay? So it's way more complicated than I thought. I'm sorry. And I mean, it's not even terrible. It's just, I feel bad I have all this repeating code with this bet logic. I'm sure there's a better way to do it. Okay. We can give them another way to quit as well, like at the very end. Hey, do you want to keep playing? You're going to stop. Print out their money. Sure. So then we'll say player bets. That's first, $2. Otherwise, the computer bets first. That's first $2. Computer, that's 1. Player bet. Those are called blind bets. Yeah, there's a lot to it now, for sure. I mean, the dealing with the class was mainly what we were focused on, but it's always this other stuff is good practice too for playing with Java. But we got it done in just over an hour, right? I think just over an hour for this demo. That's not too bad. Not too bad. All right. Any other thoughts, concerns, questions? I'll push all this out to GitHub, of course, so you can take a peek. So Hold'em, probably done. Let's see if we hit all those objectives. All right, based on the rubric. So we had private variable for 2 cards in our shared cards. Yep. We could call our compare method with another Hold'em hand. Yep. We were able to calculate best possible 5-card hand out of the 21 possibilities. Yep. Unit tests. Yep. 1 round of betting, or all the rounds of betting, 1 point per round. Right, the 4 rounds. I think we did that. Don't let them bet more money than the opponent, more money than they have. We did that. And it keeps going until someone's bored or quits or runs out of money. We did the runs out of money portion. Quitting, they just hit stop. Right? You're not actually like taking any money away. So I think we would get probably full points here. What do you think? If we did a little quick self-assessment before we submitted this. And again, you can make the computer a whole lot smarter here. Like they could raise money, they could do those sorts of things. I do want to show you one more thing here for fun. This is a really fun thing here. So with Hold'em hand, excuse me, I want to show you how we can calculate odds of winning. We're going to have a public, a double odds of winning. Okay, so our odds of winning, this will only work if we have all of our shared cards. So that's okay, right? You could do this sort of math, but it's a little bit trickier without the shared cards. But if we have our shared cards, we should be in pretty good shape, right? Let's see, so card, we can compare to, that doesn't check if they're equals, shoot. That's fine. We can do our own. I mean, so like the Hold'em hand was the bulk of it. So if you didn't get much of the Hold'em game itself, there weren't tons of points there. So like if you focused on that direction first, oh, that was the wrong button. Thanks. Right, this was only a couple points here. 8 total for the Hold'em game out of the 25. You know what, odds of winning is going to take a little bit long. Why don't we take a break first, and we can do the odds of winning after. Because this one's fun. Yeah, random stuff is really fun, King. All right, why don't we take a quick break, put some music back on, and we'll come back in about 10 minutes. Let's see, so that'll be 7:32, or no, 33? 7:33? Yeah, we'll come back in 10. All right, see you, folks.
We used to look up at the sky and wonder at our place in the stars. This is the world you've made yourself. Now you have to live in it. The end is in our sights. The future is already here. No matter how hard we tried, we are doomed. Say your goodbyes. Brace yourself. I can see the end inside. Three, two, one.
felt so alive in my life. 'Cause you make me come to life every time I'm free. Oh, and I'm loving all that you do. Can't you see that I'm crashing right into you? That I'm crashing right into you. I'm free. Oh, and I'm loving all that you do. Can't you see that I'm crashing right into you? Yeah, I'm free falling. Can you hear me calling for you? Yeah, I'm free falling. I'ma keep on falling for you. I'm free. Oh, and I'm loving all that you do. Can't you see that I'm crashing right into you? I've never felt so alive in my life. 'Cause you make me come to life every time I'm free. Oh, and I'm loving all that you do. Can't you see that I'm crashing right into you? That I'm crashing right into you. I'm free. Oh, and I'm loving all that you do. Can't you see that I'm crashing right into you? Yeah, I'm free falling. Can you hear me calling for you? Yeah, I'm free falling. I'ma keep on falling for you. I'm free. Oh, and I'm loving all that you do. Can't you see that I'm crashing right into you? That I'm crashing right into you. All I need is 10 more minutes with you. Let me give it a one last shot. Will I ever get through to you? Oh, am I wasting my time? Should I leave for the night? It's unclear at the moment. Can you give me a sign? I'm here trying and trying. I need 10 more minutes with you. So let me know if you gave up hope. Do I leave you alone or I leave you alone? So let me know if you gave up hope by now. So let me know if you gave up hope. Do I leave you alone or I leave you alone? So let me know if you gave up hope. I need 10 more minutes with you.
Hey folks, welcome on back. Man, what is going wrong, internet? Zoom this in a little better. There we go. Okay, not too terrible. It just keeps like spiking here. It's so weird. That is weird. All right. Awesome. Oh, that's right. I gotta pause that. Alrighty. Oh, this odds of winning. Yeah, I wanted to show you that. I don't know if we're actually gonna have time tonight, so we'll leave that for later. For now. To do. Okay, so I think yeah, we can do that next time. This is a fun one. Because there's 990 possible 2-card hold'em hands your opponents could have if you know 7 cards. And it leaves the 45. And then you can see what your odds of winning are, which is pretty cool. And then this can help the computer decide whether or not I should fold or not. but really only at that last round. There's other things that are already done, but if we want to do it ourselves at least, we could do that. Okay. All right, so let me start up a new project here for Chapter 10, Inheritance. And make sure I put this in the right folder, 2151. There we go. We got 2 weeks for this chapter. We won't spend too much time on it tonight. I want to get you the gist so you can get started on the project, and then we'll finish up the chapter after the fact, next week. Okay? All right. Sweet. So inheritance, and hopefully you had a chance to talk briefly about this in 1500, right, is this idea that you are a type of your parent class, right? Because this is a relationship where a square is a rectangle is a polygon. These sort of is a relationships. I think that's usually the standard example. And that's what we're looking at. So how we create these relationships, what we do with them, and then some specific cases we're going to need. So I mentioned like everything is an object. That's how we got that equals. So we got to be careful with that. We're going to look at abstract classes and interfaces. Those ones are lots of fun. I'm a big fan of interfaces. They're heavily used in the industry because they're really cool. Excuse me. So let's grab this one here. So we'll go add the. You might have seen Polygon before, but that's okay. We'll add a Polygon class. So it's a nice basic example. The Polygon has an int for number of sides, and it has probably an array list of integer for side lengths. So when you make a polygon, you're going to tell it the number of sides. Right, so this number of sides equals your number of sides. And then we got to import array lists. Then my side lengths will be a new array list. And then, for int side index is 0, side index is less than number of sides, side index plus plus. Sure, or you could just use a regular array. Again, I'm partial to array lists, so I'll take side lengths, and I'm going to add a 0 because I don't know what the length is, but I want to set up that many indexes here. Okay, and then we'll have a get number of sides. So sure, that one's nice and easy to add as a get number of sides. And then we're going to have a public void set side length here. That's going to take my side lengths. You need to tell it, right, an int side index and the int side length. So we're going to set the index to the length, right? This set method. So you tell me what index, I'll set it to the length. Great. And then a public int get side length given the int side index. We'll return side lengths. Side lengths. Dot get. Side lengths. My goodness, side lengths. Dot get the side index. Right, so if you ask for a particular side index, I'll give you that one. If you ask to set, I'll set it. I'll give you the number of sides. Right, and then Polygon can also then calculate perimeter. Parameter. Or get perimeter maybe, or something like that. Sure. So we're going to have an int for perimeter. Starts at 0, and then for int side length in side lengths, we'll take perimeter plus equal to side length. Sorry, that's all the way down at the bottom. Let's scroll it up. Then we're done, we can return the perimeter. Okay. That part makes sense so far? Just a basic Polygon class. Nothing super fancy, but you can set one side length at a time. You can get the perimeter out. Awesome. Now this one has a constructor that requires a number of sides. When you make a polygon, you have to tell me how many sides it has, and then you can't change it. Right, I should be not lazy and mark these as private. They default to private, so I'm just lazy, but it's probably better to put them in here. Okay. We could even mark this as final if we wanted. That's fun. We can mark the side lengths as final too. Sure, because they get set in the constructor. If they're set in the constructor and they don't ever change, then you can leave them as final. Doesn't matter too much. It protects you from changing it accidentally later. Okay? So then what we can do is we can write a rectangle class. And rectangle is a polygon. Right? So this kind of relationship makes sense. We say we extends polygon. So rectangle extends polygon. Rectangle is a polygon. Now rectangle we know has a length and a width, and they're fixed. So we know how many sides we have. So if we want to write a constructor for rectangle, we could maybe take an int length and width. Int width. Sure, why not? So we need to, because we are a polygon, we need to set those sides. Right? We need to create an instance of polygon, so the polygon constructor has to get called. Right, here, you know what, we'll do this. Let's let it fail first. So we'll say no arguments here, and then we'll just see if we can make a rectangle. We'll say rectangle equals new rectangle. And we'll do a polygon equals new polygon. How about given like 7/8? 5 sides, right? Why not? Okay. It crashes now. It says public rectangle requires int found no formal arguments. What was required here? It doesn't really. What's happening is because rectangle is a polygon, it has to call the polygon constructor. Because the constructor needs to run so that all of these variables have values. Losing you folks again. What is going on here? Not Firefox. What's up with Twitch Inspector? Just a spike. We back? Says I'm dropping frames like crazy. No? Okay. I guess we're stable. I don't think it is, though. Oh, no. There it is. That's sad. I think I'm sort of back. Sort of there. It's just a little bit unstable. Come on. What do we got here? Nope, still unstable. I'm sorry, folks. Okay. Cool. I don't know why Comcast hates me. Really wish I could find a better provider out here. No one else has anywhere decent speed. Oh yeah, here we go. Unstable, unstable. So I had 2 little blips. Might be coming back. Hey, are we back? All right, cool. Sorry about that. Lots of sads. Lots of so sad. Let's try going on. So we need to call this constructor. Because this constructor requires an argument, we have to give it one. So to do that, you say super, and you give it the argument. So super calls the polygon constructor. Because I know I have 4 sides as a rectangle. Easy. So it's going to call the rectangle polygon constructor now. Now it'll run. It'll be happy. Okay? But really, we might want an int for length and an int for width. Then what I want to do is I want to set my length and width. So I might have a method for set length, int length. And so lengths then we'll say maybe are 0 and 2. So we're going to call set side length, index 0 to the length, and set side length, index 2 to the length. Now, it lets me do this method because I am a polygon. I have all of the methods of polygon. All the public methods of polygon I have, because rectangle is a polygon. Then we can do set width. Int width does the same thing, but we're going to do, how about 1 and 3 are the widths. So if you tell me a length and width, I'll call set length, given, no, set length, given the length, and I'll call set width, given the width. So I've got a nice easy shortcut here for setting the length and the width. So how about 4 and 2 here? We should be able to get the perimeter. So my rectangle, perimeter, rectangle, perimeter. It should be rectangle dot get perimeter. Get perimeter is a method in Polygon, but because rectangle is a polygon, it's inheriting from Polygon using this extends keyword here. It is one of these. It can do all of those public things, right? And this kind of follows the idea that we're doing these things in an object-oriented manner, because inheritance, we're very familiar with that when we deal with real objects, right? You have a person. A teacher is a person. A student is a person. But they're different types. They're a special version. So what inheritance lets you do is it lets you do all of the things a parent class does, and then you get to specialize it. You get to add functionality and features to it to make it special and unique. So we should get back a perimeter of 12, right? 4 plus 4 plus 2 plus 2 is 12. Looking good so far. Other cool things we can do is we can get area. Right, so we're going to return get side length of 0 times get side length of 1, length times width for my area. That shouldn't be void, sorry, as an int, get area. Okay, now the problem is though, because we are a rectangle, what happens, or because we are a polygon, what happens if I say set side length? And I say, oh, let me go to Polygon and change just one of those. You're no longer paired. So now we're going to have a problem. So the other thing we can do with this inheritance relationship is we can override the behavior of our parent class. We can say, you know, I like what you do, but I want to do it differently. So we're going to say at override and add this little tag and tell Java, hey, I really want to override my parent class here. You know, we've done this with toString because object had a toString method and we were overriding it, right? So public void set side length, given an int side index and an int side length. Right, we're going to say if side index mod 2 is 0, right, so 0 or 2, sure, or yeah, sure, equals 0 or side index equals 2, sure, that's probably better, right? Then we'll call set length, given the side length. Else if my side index is equal to 1, or the side index is equal to 3, set the width, sorry, set width. Set width, given the side length. Now, this is actually going to cause a problem here in a second, and you'll see, we don't actually want to do that. You'll see, it's going to crash on us. Ooh, Stack Overflow, because rectangle set length says set side length. Set side length says set length. Set length says set side length. And we're bouncing back and back and back and forth, back and forth, back and forth. We have a problem. We overrode our parent class's behavior, but we really want to do this parent class behavior here. So what we can do, we say super dot set side length. We're telling Java, hey, please use my superclass's version here, not my version. So we were skipping this one. That's going to call us again. We're going right to the parent class for that. Okay, so now it's going to run, because now we're not going to have that infinite loop of back. And now if we do happen to say, oh, hey, I want to set one side length, it's going to set both of them. Hey, you changed the length? Great, you changed it. You're still a rectangle. Otherwise, you wouldn't be a rectangle anymore. Okay, so it's rectangle is a polygon. It extends polygon. Okay, that's the is a relationship. And we can go even further, right? We can make another class here. Implement a new class. Let's make a square. So then square will be a rectangle, right? A square is a rectangle, so it extends rectangle. No, rectangle. Okay? So my rectangle constructor needs an int length and width. So I need to have a constructor, int length, that calls my superclass constructor. So we're going to say super, and we're going to give it the length and length. Right? And then we want to override set side length as well, so that no matter what it is, right, we're going to set length and set width. Right? But we also want to change set length and set width. We want to override these because they need to both happen. Right? So we want to override the public void set length, int length, and we want to override set width. Because I don't want one to change without the other. Well, what do I want it to do? Well, I want it to set length and set width. So I'm going to, I don't know, I could do that. We could just set them both. Yeah, we'll just set them both here. Just set them both to length. But I want the superclass version. I don't want mine, which is going to do both. I want the superclass version. Right, because superclass is going to mean, hey, go to rectangle, call set length and set width. Which says, okay, go to polygon, set side length, set side length. Because that way when you set side length that I'm overriding, you'll call my set length and set width, which says, oh, call the superclass set length and set width. And really, we only need to do one, right? Because one will trigger the other, which is kind of fun. All we really have to do is set length. Set length will set length and width to that one. So if you set any side, we set length, and setting length sets both lengths and width. If you set width, it also sets length and width, because we're a square. Okay, so we can make a square. Square is a new square. How about size of 10? We'll have a perimeter of 40 and area of 100. Ornog, I'm sorry, I don't even follow that question. I'm not really sure. All right, so we got a square, and then we can say do the same thing, right? We could get the perimeter. So square perimeter is square dot get perimeter. We can also get the area, right? Might as well. Let's do area as well. Area, get area, and then square area as well. Area, get area. Okay. So rectangle area should be 8, square rectangle area should be 100, perimeter is 40. Right, looking good so far. You all right so far? Again, this is a relationship. So if our parent class has a constructor, we have to call it, and this has to be the first thing we do. Calling your superclass's constructor has to happen first, because Java doesn't know if you depend on any of their other functionality. Right? There's no guarantee whether or not it's going to work if your superclass hasn't done its constructor, right? Because if we're calling like set side lengths and we haven't set up that array list, it's going to crash, index out of bounds. Right? And it'll crash real hard. Okay? Let's see here. Let's see. I had a student one time who took everything way too literally, and I didn't realize it at first. But it dawned on me when he came in and said he ate his homework. And I said, well, why did you eat your homework? And he said, because you said it was a piece of cake. All right, that one was only an okay one. All right, what kind of jam cannot be eaten? A traffic jam. Was that better than the piece of cake one? I don't know. All right, so this is creating the is a relationship. Right, there's a lot more to it. We'll get into more of it later. I also want to show you an interface. Yeah, we're going to go a little longer tonight. I wanted to wrap up earlier, but that's okay. So let's look at Polygon here again, and let's say, hey, we want polygons to be able to figure out their areas. So what we can do is we can say, okay, well, let's do all these things Polygon does, but how about we add a method here, like public int get area, and we just let the classes that extend us, that inherit from us, figure it out. Well, I actually can't calculate the area for a polygon. That just doesn't work. So what we can do is we can say, hey, this is an abstract method here. And if you say if it's an abstract method, we don't have any curly braces. We just have a semicolon. We say there is a method named getArea. You have to implement it. You have to add it when you create yourself. And now it's upset because Polygon is not declared abstract. We want to make that abstract. So public abstract class Polygon. So you can do this thing as an abstract class, which means you're mixing and matching. You're going to say, hey, I could have some functionality, and you have some methods, but I'm also going to have some methods that you have to have, but I'm not going to write for you. And then what you do when you extend them, you will override or implement those methods here. So we're going to, oops, here's my little light bulb. Add the override. Yep. We're going to add the getArea here. Because when you extend an abstract class, you have to implement all the abstract methods. And that might seem a little bit silly here, and that also means now I can't make polygons. If you have an abstract class, you can't make them. So I can no longer have an actual polygon. But what's crazy here, and this is really fun, so this is one of the fundamentals of object-oriented programming. So we're talking about inheritance. Polymorphism is a really fancy term for being able to treat an object as its parent type. So I can make an array list of type polygon. We'll call this shapes equals a new array list of type polygon. Not sure, diamonds. And shapes, now I can add the rectangle. And shapes, I can add the square. Because they are a polygon. Like, that inheritance means that they are polygons. I can do this. Okay, let me back this up 1 second here. No, that's fine. That's fine. So what I can do here then is I can say for polygon shape in shapes, let's loop through. We'll print the perimeter plus the shape.getPerimeter, and I can do the area as well. Shape.getArea. Because Polygon has a method named getArea, the Polygon class has a getArea method, it's abstract. But I know that if you're a polygon, you will have a method called getArea. And I can put any child class in because it fits and looks like its parent class. It is a type of its parent class here. Now what I can't do, there we go. There's only set side length. There is no set length, there is no set width method here. Because Polygon doesn't have set length and width. That's a concept that was added by Rectangle. So when you treat something as the parent class type, you only get the methods that are in the parent class, that are in this class here. But because getArea is here, we can use it. We get our perimeter, we get our area. So maybe we want to add something here. Let's go back to Polygon. Let's add a string for name. A string for name. And then we'll add a get name. Look, string. Get name. Return the name. And then maybe we'll add that to our constructor. So we'll have a string for name and the number of sides. Like this name equals your name that you gave me. Now, Rectangle and Polygon now, they can't just say number of sides. So we probably also need a string for name. And I can just pass that argument through to this constructor. So if you don't know what the value is, if it's supposed to be provided by the person creating your object, you just pass it through. Right? Same with square. String for name, you just pass it through. Okay, so when I make a shape here, we'll call this one rectangle 1. Call this one big square. Right, and now I can get the name out. So shape plus shape.getName. And get the names out. That make sense? So what's happening when we add that to the Polygon constructor, we have to call it. So we need to take that as an argument. If we don't know what it is, sure, you tell me what you want to call it. Big rectangle, small rectangle, silly rectangle, anything like that. Go for it. But we can treat them, this is polymorphism. We're treating the child class type as its parent class. So rectangles and squares are polygons, because a square is a rectangle is a polygon. You can have as many levels of these as you want. The Java API does this all the time. So if you ever go look up the Java API site, Java API, we're on 8, right? API 8. And you look at some of these classes here. Let's see. Let's find like a fun one in here. Sure. How about a MIDI event? Okay, no, that one's just an object. That one's not interesting. How about a monitor? A monitor is a notification broadcast support, which is an object. So there's some extension there. How about a print service? Oh, that's just an interface, sorry. How about a progress bar UI? A progress bar UI is a component UI, which is an object. Right? We're doing this inheritance thing all the time. So it's telling you, hey, it extends component UI, and progress bar UI is an abstract class itself. So you can't make one directly. And how about a reader? That one's not interesting. Rectangle. Well, there's a rectangle class, which extends from rectangle 2D, which extends from rectangular shape, which extends from object. It implements some interfaces. Look at that. Default caret is a rectangle. Sure, why not? So we use this inheritance all the time, and it's all over the Java API as well, where types are their other types. Right? You are a version of your parent class. Okay? So with an abstract class, you say, here I have some functionality, but here's a method you have to have. Sure, why not? Now, the other thing you can do is you can make an interface. Now, we did that, we implemented the comparable interface, which is a lot of fun. So I'm going to make an interface here, and let's call this one, how about, we'll say, what do we want to do with these? What do we want to add? We're doing shapes, right? I don't know, we'll call this the has volume interface. So an interface is essentially an abstract class with nothing but abstract methods. So it's like you might hear in another language as pure abstract. If you come from C++, a pure abstract class is essentially an interface. So all an interface does, and technically you can do like 2 other things, but we're not going to worry about those because they're confusing. If they just list a bunch of methods. We're going to have a public int get volume. Sure, that's it. So if you implement this interface, you'll have a method for get volume. Why not? So let's add another class. Let's add a, nope, not an interface. Let's add a class. We'll call this cube. Okay. So a cube, we're going to say extends square. So a cube, it's not really a square. Maybe this doesn't fit exactly, but it is a square. I mean, sort of. It's a 3-dimensional square. How about that? I'm not going to feel too bad about it. We're going to call our superclass. So we need a public cube. It needs a string for name because we need to call our superclass, and it needs an int for length because we're going to call the superclass and give it the name and the length. And then we're going to say we implements the has volume interface. And then NetBeans says, no, you don't. And we say, okay, yeah, please implement all the abstract methods. And the default is silly. It's all right. Just get rid of that. So get volume then, we're going to return my get side length of 0 times the get side length of 0 times the get side length of 0. Right? My length cubed is my volume. So the reason we have this interface here is that it's sort of like a contract. If you implement an interface, you're guaranteeing that you will have that method. Okay, and now circle is really tricky. Circle, I think, is technically a polygon, but it's like an infinite polygon. I don't know. Probably not. We should get someone who actually knows about math and geometry. But like circle could have a volume if it was a cylinder. Right? We could add like a cylinder class here, and we could have cylinder extend from circle if we wanted. Sure, and calculate this sort of thing. We could do that. So let's add another class. Let's add circle. So circle needs a private int. Sure, why not int? What, radius? And a private string for name. Private string for name. So public circle needs a string for name and an int for radius. This radius. Oh, you know what? It can do it for me. I always forget. I like using this generate code. Insert my constructor, please. Look at that. Insert my gets. Gotta use this more often. Okay. And then we can have a public double get area, right? Definitely don't use an int for get area. We're going to return radius times math.pi. Pi r squared times radius. So radius times pi r squared for area, right? A public double get circumference. Right, that one's pi d, so we're going to return pi times radius times 2. Right, put the multiplication sign in the right spot. Right, pi d, diameter being radius times 2, sure. A circle has one side and infinite sides. Man, that's some heavy math. Sure. All right, why not? So it's a circle. And now let's implement another class. Let's do this as cylinder. Now, cylinder is technically a circle, but it's got a third dimension, right? So we're going to extend circle. And we're going to implement the has volume interface. Why not? I was going to say, no, you don't. So yeah, please. Let's implement our abstract methods. Get volume. So cylinder needs to know an int for height. Right? And then we need a constructor. So let's add a constructor that needs a height, a radius. Look at that. It even knows radius and name. How smart is that? It gives me radius and name. Now, I'm going to do those backwards, though, because I want name first, and then I want radius, and then I want height. Because I think it'll match better. Okay? Set the height to the height. Call my superclass here. We're good to go. Now, volume, then, is going to be return get area times height. Right, the area times the height is the volume. Oh, that should be a... Ooh. That needs to be a double. Uh-oh. Double get volume. Okay. Uh-oh. Has volume should probably be a double then. My bad. Double. Okay. Now we're better. Okay. And then if we want a bunch of shapes here, this needs to be a double, I guess. Sure, why not? If we want a bunch of shapes, then, that have volumes... You can do the same sort of thing here of the interface type. This is going to be a has volume interface. 3D shapes. 3D-dimensional shapes. Sure. And by 3-dimensional shapes, we can add the square or the cube. That's right, we need a cube. Okay, we need to make a new cube. So we'll add a new cube given QB and 10. And then 3-dimensional shapes, we can add a new cylinder given, what do we want to call this, like an axle. right? Its radius is going to be small, maybe 2, but like a super long length, maybe like 20 for a height or something. Like if you're doing that axle all the way across here. And then again, we get to treat them then as a three-dimensional shape. So the only thing we can get out of them is their get volume, because we're going to treat them polymorphically as their interface type. So you can do all sorts of these mixing and matching, putting things places here and there with inheritance. It's a lot of fun. All right, I'll push that out. Okay. We all right so far? Why don't we talk about the next project? So that we can get started on that one, because you're all going to start much earlier than you did on this project, right? Project 2? You're going to start it early? Let's see. I got lots of questions today, which is a rough time to be asking questions. So let's do start earlier. Okay, so let's make a new assignment here. For project 3. Okay, due in 2 weeks. 2 weeks from tonight by 6 p.m. We need to have this one in. So we add a new grade item here for project 3. New projects, awesome. This one will probably be maybe 30 points. Okay, and I'll add a rubric in a little bit here. All right. Oh, I left my beverage downstairs. I got some milk. I had milk and cookies. It's a fantastic snack. All right. Uh-oh. What is going on here, friends? Are we still there? So they have no bits. No? Maybe I'm still here? I'm not sure. Alright, I think I'm back. Alright, are we back? Maybe? Okay, cool. Sorry. I think it's just being really funky tonight. Alright. So we're going to do a little game here, because I think games are fun. And we're not going to do a lot of it, okay? So we're going to take like a bigger idea and do a really crappy version of it. Is that fair? All right, so we're going to create a game. Oh, you need a Google Classroom or GitHub Classroom link too. Give me a second. GitHub Classroom. I'm going to get that link here so you can get a new repository. There you go. 3. Project template. There we go. No, that's not right. Shoot. I'm gonna find my template here. I'm sorry. There we go. There it is. All right. Okay. So please submit the URL to your feedback pull request along with a self-assessment using the rubric. Okay, let me know what points you got here and where. All right, so we're gonna make a game. It is Animal Craft. Okay? So this is a game totally unrelated to any game you've ever heard or seen before. Definitely not related to Minecraft or Animal Crossing. Okay? Don't have any preconceived notions here. So Animal Craft. Okay? We're going to have a couple different concepts we're going to be building out. Okay, so we're going to have a player class. Okay? With name. Sure, we'll keep adding as we go here. We're going to have an island class that belongs to player. Right, or sure, it has an island. Right, so the island class then has a bunch of spaces. Okay, so your island is essentially like sort of like a 2D grid. A bunch of spaces on it. Okay? And then players will have friends, a list of friends, which are other instances of player. Right, the island class, right, that's your main island, and then you'll be able to go to your other friends' islands as well, and we can interact with them. Okay? The one weird free sandbox mobile crafting building surviving game is very buggy. I don't exactly know. We're just trying to take a couple of these ideas here and see what we can do with it here. Okay? So, each space has a description. So we'll have a space class, right? Space class. Space, I don't know. I can't think of a better term for it, like tile, maybe. A bunch of spaces, tiles, sure. Has a string description. I mean, you can visit your friends' islands, so we're trying to take some of these ideas here, some of the fun stuff here. So you have the string description, and then we're going to have a couple interfaces. So we're going to have an interface for. So what are the different things that we do on tiles or spaces? Like you can build on them, or you can put a farm there. I don't know. There's all sorts of fun things you can do. So we'll have interface for things like is buildable. Allows you to build on the space. Essentially, if we build on the space, we're just going to change the description. Okay, so like if you can build on this space, when you go build it, it'll change the description of the space. So it's initially like, here's an empty space, and then it will go build something, and now there'll be, here's a tree on this space. Sure. Yeah. Things like, is buildable. Yeah, sure. Is diggable, which allows you to dig a hole in the space. Also changes the description. Right? But like when you build something, you can pick anything you want. When you dig, it's just going to be, now there's a hole here in this space. Okay, this little 2D grid, here's rows and here's columns. We're going to put spaces in all of them. Okay, and we're going to have a set of tools. So a tool class that allows players to build, dig. I don't know, what other things do you do? There's something about picking up bells. I don't really understand the whole game. My kids like it. I've not yet got into it. And what other tools do we need? For building, for digging? Yeah, not Stardew Valley. We don't do anything that crazy. Okay. So the player can pick up tools from random spaces in their island. We don't need to worry about any crafting. I think that would be more complex than we need. Like where you could craft your own tool. So we'll just say, hey, at this space, there's a tool you can pick up. Sure. So some spaces have a random chance of having a tool can be found. Sure. So if you move around the space, it'll tell you, oh, hey, there's a tool here. Do you want to pick it up or not? And you can pick it up. So then the player has a list of tools available. or tools picked up. Okay. Yeah, so then the player can move around their island or travel to a friend's island and move around. I'm going to give the description. Description. I can't type tonight, sorry. The space, along with any tools they can pick up. Yeah, I mean, come up with some tools. Axe, shovel, trowel, that's fun. Certain tools can build certain things, right? Is choppable, which allows you to cut down the tree in the space. Sure. Big chop, dot, 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 dot. Yeah, I mean, you can go nuts here, right? They can pick up tools from random spaces. If they have the correct tool and the space implements the correct interface, allow them to use the tool on the space. So not all spaces will be diggable, not all spaces will be buildable, not all spaces will be choppable, but if you find one, right, we can do this sort of thing with it. We can interact with it here. Okay? Sorry, just 1 second. Almost done. Okay, so this idea, this animal craft, you can run around, you can build things, you can make a really pretty island that your friends can come visit here. And then, yeah, when you travel around an island, move around. So you can always edit your island, right? You can always do stuff on your island, but unless your friend has designated you as, I forget, what is it? You need like some special permission to be able to edit their island. A trusted friend can only view their island, can't edit it. Sure. Why not? Okay. We're going to add all these things here. So let me add a new rubric. This is project 3. Okay. So it's missing or it's complete. So this will be the player class, right? We got 5 points for player class. Island class. We'll do 5 points for the island class. Interfaces. 5 points for interfaces. Tools. 5 points for tools. What else do we have here? And then designation for I don't know, friend functionality. Visiting versus editing someone's island. Right, and I think that makes 30. Oh, no, did I count wrong? That's only 25. Player, island, interfaces, tools. What else do we have there? Stretch, yep. It's supposed to just sort of like a silly Minecraft Animal Crossing mix here. We're just running around. I need more points here then. Player, island, interfaces. Here, let me... I hate that it doesn't show me the description. What did we already write? That's not even, it doesn't even exist. That's fine. I'll come back and add more later. Yeah, player, island, oh, the space class. That's what it was. Gotta edit that rubric for spaces. There we go. That ought to do it. Let me go to my rubrics, and I'll go change that one. Rubrics. There we go. Space class. Spaces. We have random items, or random tools, or implement interfaces. This is the interfaces themselves. That's the island class. Basically a 2D grid of spaces. interfaces with method names, tools, allow the player to use the correct tool or the matching tool on a space with the matching interface. So if you have a axe tool and you come to a space that is choppable, right, and the space says, hey, I have a beautiful tree, you can chop the tree down, and then you can build something, right? That's that sort of thing. Okay. This one's real open-ended. I want you to just kind of explore and play with how we can build these things out, how they can interact. We'll talk more about it next week as well, and we're running a little short on time. We've already gone over a lot. But any way that you wanted to design it is cool, right? The idea we'll just have something we can kind of explore. So it starts up, hey, you're so-and-so, you want to play, you want to visit your island, you want to go to a friend's island. Give me a friend code, that sort of thing. We'll go look up a friend's island. Sure, why not? And you don't actually have to have real friends' islands. We don't have to build all those out. Or we could randomly generate them. That's probably easier. Or if you just want to build, here's an island, here's like a 10 by 10 set of spaces that are hard-coded in there, that's cool too. So if going random, it's fun. Building out your own is fine. Any way you want to go about that's okay. We can look at some different approaches. And then you just kind of walk around. Hey, I want to go up, I want to go down, I want to go left, I want to go right. And then what's at this space? Tell me what it looks like. How do I interact with it? Types of noises. Don't actually know what those are, King. Alright, I think that's all we got for tonight. We'll come back next week and we'll finish up Chapter 10, talking more about inheritance. We'll get working on this project. Pick a spot and start trying to add some features to it. Right? And to kind of build on it iteratively. So build a little bit, get that little bit working. Build a little bit, get that little bit working. Build a little bit, get that little bit working. Right? If you want to start with, here's a bunch of spaces, and they're all empty to start, sure, and then we go put some random tools down. Cool, now I have some tools. Then maybe I can start making the spaces implement some of those interfaces. Sure, and if they implement the interface, do I have the matching tool? Can I do that right thing? And then we can do the friends part later. Right? A friend is just another player. We can be we can go to their island if we have the right code, something like that, and then they can either say we are allowed to edit their island or not. And then, that's all. We can just code that in there. Random terrain generation. Yep, very cool. Okay. Yeah, I'm sure there's a lot of stuff that goes into that. All right, so why don't we call it a night? I'll be around tomorrow is Wednesday, 3 to 4:30, and 10 to 11. If you want to drop in for my office hours, we can chat about anything. Feel free to ask questions in the Discord. That's a great place because then other people see your questions and their answers. We can have a good talk there. And, if you folks want, I think we're fine. I think it's fine if you want to work in partners in this one. As we get closer to our final project here. The final project, ideally, we're going to do with partners. I'm not going to make you, given this remote pandemic learning. But if you want to work with a partner on this, let me know. I can set up a repository that both of you have access to, or you can share code any way you want. The repository is a little bit tricky here or there, but that's okay. So let me know, or just kind of collaborate and just, work more closely than you did before. Okay? All right. So why don't we call it a day? Let's head over to someone else. We'll learn some psychology here with our friend Site Queen. And yeah, let me know if you have questions, thoughts, concerns. Happy to chat with you folks about it. Hey, Journey, hi, wave. Say hi.
Hello.
All right. You folks have a good one. Let me know what I can do for you. And if not, I'll see you next week. We can talk more about it and finish up Chapter 10, Inheritance. Thanks, everybody. Yep.